welcome to Real Nose Engineering. In this video, I'm going to discuss about the inside mechanism of ChatGPT or how ChatGPT is trained. So let's begin the training. So what is ChatGPT? Chat means we all know exchanging of messages in social media. What is the full form of GPT? GPT means generative pre-trained model. So why generative? Because it keeps on generating text. Okay, why pre-trained? Because it's on the top of a pre-trained model, that is your GPT series. We are going to GPT 1, 2, 3. In this series, it is on the top of a pre-trained, already trained model, so it's pre-trained. Why transformer? Because at step number 1 of the training process, extensively transformer is used, so it is transformer. Let's move to the step number 1. And there are total 3 steps. In step number 1, extensively and only transformer is used. In step number 1, a huge amount of data, you can say 100 trillions of data are used, like from web crawlers, from internet, by data scraping and everything. There is huge and vast amount of data are collected from, and this is used given as training to the transformer. In this basic of transformer, I would like to discuss that a transformer consists of 2 important parts, that is encoder and decoder. There are 6 number of encoders and 6 number of decoders, and a bit high level has 12 number of encoders and 12 number of decoders, right? So here the English like word is inputted to the encoder, okay? But one thing I'd like to also tell, like the English language is very easy for us to understand. Like we can easily communicate with each other. But for a machine, it's a very difficult part. Like they don't understand the English language. We have to move from a 0 level to that high level because they totally don't understand the English language. So the English language has to be converted to a machine level language so that the transformer, the machine, can understand it. So this is the part of the game which is very, very important, right? So I'll give a simple example in this case. Like if I will input the sentence, the cat dash on the chair, the cat dash on the chair, and the transformer needs to predict the or fill up the blanks. Okay, so this sentence is inputted inside the encoder. Okay, and what the encoder do, like it takes the sentence and it divides each sentence into words, single words, and each word is again divided into tokens. Okay, each word is generalized as tokens, and again these words are converted into integer, or we can say numerical part, because the computer transformer cannot understand what is a cat and everything. So these words are encoded into number, or you can say integer part. Okay, but in this process of converting or encoding the sentence into number, this is a huge process. Okay, that is the full process of transformer. I can explain in a video. For now, just understand the words are converted into numerical part or vector form, or you can say a matrix form. Each word consists of a matrix form. Okay, and these mathematics, after doing all this mathematical and statistics, the encoded sentence is again inputted to the decoder. Now the part of the decoder is to fill up the blanks and generate the output to the human user. Okay, now the decoder will try to decode this English language. Now the decoder will try to decode these numbers from its pool of dictionary. How it can decode? Like we have a dictionary, we refer the dictionary for our knowledge, for our vocab knowledge, right? So in the pool of the dictionary, there is also a pool of dictionary inside transformer. Okay, and inside the pool of dictionary, like we understand the meaning from our dictionary, in the same way each word has a numerical meaning in the dictionary of transformer. So the transformer will try to interpret the English meaning from its numerical form, right? So the decoder will try to correlate what is the meaning of, like suppose there is 0.9. What is the meaning of 0.9? What can be the English like word for 0.9? right? So the decoder will try to decode the things, like if I say the cat dash on the chair, so what is the probable word? The probable word is jump, right? So how it will decode? It will give a numerical value to each word, like the in the sentence, the is not much important, so it will be like some 0.01 value, but the cat is an important part in the sentence. Through the cat only we can predict the word jump. The cat can jump, right? So the cat will be given a more probabilistic value like 0.9. Okay, then the fill up the blanks, the cat blank on the floor. Okay, and again the next the is not much important, it will has a less value. So the cat mask on the chair, and the chair has also a greater probability. Okay, it will also get some probable value between 0.8 0.7, and on has also a middle level probability. By checking these numerical probable values, the pre-trained transformer will determine, okay, the predicted word can be the cat can only jump on the chair, so the word is jump. Okay, in this way the decoder will decode the sentence. After decoding, how it will decode? It will get the numerical value of jump and it will fill inside the blank. Okay, after getting the numerical value, it will decode these words into its English form. Okay, after correlating its English form, it will give the output sentence. So in the output you'll get the cat jump on the floor, so you'll get the answer. If you ask the question the cat dash on the floor, it will give you the answer the cat jump on the floor, right? You get the answer. Okay, so this is the mechanism of encoder decoder. And one more important thing in transformer is the self attention layer. This is the most important layer of transformer, for which differentiate it from your LSTM, your recurrent neural network. Okay, because transformer has a mechanism of self attention layer which these LSTM doesn't have. Okay, so this self attention layer gives the attention mechanism to each word of the sentence or each token of the sentence. So its mechanism give a attention mechanism to cat, to chair, to the preposition on, and it gets the word jump. So this is a uniqueness and innovativeness of transformer which other like LSTM and recurrent neural network doesn't have. So it's a very easy part for the transformer, this attention mechanism given to the word, like it can give attention to the words which can give the answer to the sentence. Okay, process that can be a separate video on transformer. Okay, for now it is important that transformer has self attention layer. And 2017 there is a paper, all you need is attention. This is the first paper on transformer which generates a boon in the area of artificial intelligence. It's give a changing part in the area of artificial intelligence, right? So now it's all about the step number 1. Okay, in step number 1, the ChatGPT is able to do what are the things that ChatGPT is able to do is that it can summarize the text, it can fill up the blanks. Okay, it can give you the question answering things. Okay, but only text summarization, question answering, and like what, fill up the predicting the next word, this is not the only thing we want from the ChatGPT. We want the ChatGPT to behave like a human like agent which can chat with us, which can answer you each and every question and answer. But it doesn't happen in real, right? It doesn't happen in real. So in step number 2, to overcome these problems, so in step number 2 we go for supervised fine tuning. Okay, I already said there are 3 steps in training of ChatGPT. First one is pre-trained through transformer, the second one is supervised fine-tuning, and the third one is reinforcement learning through human feedback. Okay, so these are the 3 steps of transformer. Now come to step number 2. And step number 2, what happens as there is some lacuna in step number 1, the ChatGPT doesn't behave how we want. So in step number 2, what happens? It tries to mimic human conversations. How the things takes place as like it takes the what happens a human AI trainer. Okay, chat with another human AI trainer, and the second, suppose there are 2 human AI trainers, suppose first is I and the second is you. You act as a chatbot and I act as a human being chatting with you. right? And I ask you question and you try to give the answers like a chatbot can response. So these chats keep on they going on chatting, and it creates a lot of datas. Okay, and also it takes the datas from the previous history of chatbots. Okay, but it still doesn't create the much amount of data, like around 15k 20k, this much of data is created, but actual data set is used 100 trillion data. So with less number of data, it is not possible to fully train ChatGPT. So after doing this, it creates an amount of data which is fed as an input to the ChatGPT. Okay, but it doesn't create more data. It creates some around 15k 20k of data, which is very less. So I can tell you what is the phenomenon, like so I can explain you this with an example. Like a teacher is making a computer understand a game. Suppose a computer doesn't understand a particular game and a teacher want to tell the computer what it will tell. It will tell you the basic rules and how to play the game. Okay, so the computer will know the basic rule and it tries to play. The teacher will also tell you that where you are wrong, how you can play the correct thing. It will tell you, kick you at the point. The teacher can also guide you where you are wrong, how to play the game to score more. Okay, total guidance process will take place, and finally the computer will learn how to play the game. In the same way here, this is the example, but how the machine can understand, how the machine can really mimic the human conversation. For this, the algorithm used is gradient descent algorithm, right? By the use of gradient descent algorithm, the computer tries to minimize its cost function. Okay, when these AI trainers chat is inputted to the ChatGPT, and the next responses are judged by the trainers, that how the ChatGPT is reacting, giving the answers. Okay, so this gradient descent function, what it does, it tries to minimize the loss function. Like it tells the ChatGPT, when the ChatGPT give a very good response, okay, so the loss function is minimized. If the ChatGPT doesn't give a correct answer, then the loss function is increased. Gradient descent function will do, it takes a time, it takes small data set and it tweaks the parameter that, okay, at this point your loss function is minimized. Okay, so it updates the parameters of ChatGPT when the loss function is minimized, and it keeps on repeating tweaking the ChatGPT, and it tries to minimize the loss function, and the parameter gets updated each and every time. So in this updation process, the ChatGPT learns how to mimic human conversation. Okay, so this is your step number 2. This step number 2 has also some lacuna, for which they have to move to step number 3. What's the lacuna? This is the lacuna of the problem of distributional shift came. So what is distributional shift? Like two AI trainers converse with each other, and these data are fed into the small brain of ChatGPT. But the ChatGPT doesn't know the whole world, right? It only knows how much information, how much conversation you have given to it. But if it's beyond the area of ChatGPT, beyond the area of ChatGPT, it will not give you the correct answer. Beyond, someone will ask some question which it has not been trained, it can answer only the things which it is trained, right? So it will just freak out, it will give you some heretical answer. So this problem come because a small amount of human brain is fed into it, but still the world is very vast. Okay, so this is called your distributional shift problem. For this we go for step number 3, right? So in step number 3, the name is reinforcement learning through human feedback, right? In step number 3, the reinforcement learning is applied with a uniqueness of human feedback. Okay, so how these things takes place, like I've already told you that in step number 2, the datas are not very large. Okay, we can generate very large amount of data. So to overcome this problem and also to overcome the distributional shift problem, what they do, the AI trainers try to chat with the step number 2 ChatGPT, that is the supervised fine-tuned ChatGPT. Okay, this ChatGPT is now supervised fine-tuned. Okay, the trainer tried to chat with a supervised fine-tuned ChatGPT, right? And it ask questions to it. It asks the question such a way that it gives alternative answers for a single question. Okay, it gives alternative answer for a single question. The trainers ask the question in such a tricky manner that ChatGPT give four. If for example, I'll say four answers for a single question. Okay, now what happens? Another AI trainer label these answers of the ChatGPT. Like out of the four answers, the best answer, the mid-level answer, and the worst answer. Okay, it try to label, rank the ChatGPT, right? And what now the mechanism of reinforcement learning comes. So here what happens, like if the ChatGPT will give you the best answer, it will give you a reward. And what is the reward? Like a simple example, like a master tries to train her dog. Okay, and the master wants that the dog catches the stick, and the master throws a stick and the dog will catch the stick and comes back to the master. Okay, so and if the dog comes back with a desired stick of the master, then the dog will be rewarded with his favorite food, favorite treat. Okay, and if the dog doesn't, then the dog, it will not be rewarded. So slowly and steadily the dog understand, okay, if when a master throws a stick, if I get a stick, then I'll be rewarded, I'll get my favorite eatables. If I won't, I'll be punished, I'll not get anything. Okay, so slowly it understand, and each time when a master throws a stick, it gets the stick back to the master. Okay, in the same way, this is a process of reward model of reinforcement learning, and the AI trainers want the ChatGPT also understand this process. Okay, understand the labels or the ranking of the answers. Okay, so what they do, they try to reward the ChatGPT model. They try to give you a score to the ChatGPT model. Out of the four alternatives, as I discussed before, if it will give you the best alternative, it will get the highest score, and if you get the worst alternative, it will get the lowest score. And through this process, the ChatGPT understand that if I can give the best out of best answer, I will get a reward, and my reward is my score. And if I can't, if I go for a least correct answer, I'll not get any score, so this is my punishment. Okay, so through this whatever I'm telling, this is we can understand, it's a human, we can understand, but how the machine will understand? And this the machine can understand from the algorithm called standard cross entropy. Here standard cross entropy algorithm is used, and it tries to minimize the loss function. Whenever the ChatGPT will give the best answer, the loss function will be minimized. When ChatGPT will give a way off answer, then the loss function will be high. Through this, applying this mechanism, the ChatGPT understand that, okay, I have to give a bestest answer. Okay, so it gives a export policy and it tries to give the answer. Touches the reward model is final touched by your PPO model, that a final model applied in ChatGPT, that is your proximal policy optimization. This PPO optimization is given to the reward model. Okay, as we know, in reinforcement learning there is different type of policy. The particular policy applied in this reward model is proximal policy optimization. Okay, so this is a very fancy and good algorithm. Okay, it's an advantage function to calculate what is the best function, what is the lowest best function. So this PPO makes a great work in calculating and evaluating the ChatGPT best answers. So after this, the ChatGPT is able to act like a human being, and it is able to converse like a human being. Okay, so but still there is some point. What is the point? After this doing this rigorous training process of this reward model, there is a time come when the ChatGPT's score reward is going on increasing, but the ChatGPT is not following the instruction, not answering correctly. So this is basically a problem. This is basically a problem which comes. So this is a still this is a very big problem, context for them, but is still a big problem arises. That is the reward of ChatGPT, the score of ChatGPT keeps on increasing, but the ChatGPT is not working correctly, not giving you the correct answer. So this problem arises after applying the PPO technique. So this is a very big problem for them. They sorted this problem also is sorted out by the trainers. What they do, they applied the KL divergence, that is your callback Libler divergence. So when the KL divergence is very high, that means the ChatGPT is getting the reward but not answering correctly. So it tries to KL divergence tries to minimize its value. It's try to keep its value as low as possible. And how it does, it tries to understand that how much information is lost when one information is used to get the another answer. While taking first step to get the another answer, how much information is lost, this information is kept by the KL divergence. Okay, and in this way it also eradicate this problem. So this is the whole training process of your ChatGPT. Step 1, in step 1 a transformer is in throttle and 100 trillion data sets are used. Step number 2, it tries human tries to it tries to mimic like human being. Okay, human being tries to make the ChatGPT understand through standard cross entropy. And step number 3, your PPO policy is used and KL divergence is used by rewarding the model through human feedback, like directly human chat with ChatGPT and tries to make it all sort out. So this is the whole process of ChatGPT. I think you are getting the things clear. I try to deliver much of the knowledge which I can. Okay, I try to deliver it. So I hope after watching the video you can understand what is the process, overall process. And if you want a specific video on transformer, a specific video on reinforcement learning, I can make a separate video for it. Okay, so if you like the video, subscribe to the channel, like the video, and thanks for watching.